Right. Um, back to back to where save change the title. Okay. Okay. Oh, it says cancel here because I could have canceled. Okay, Cup. Welcome to the second half of the second class of data analytics for the fall or autumn 2024. Okay, in the first half, introduced to you Mathematica as a programming language and Wolfram as an ecosystem. So basically think of this whole computational platform, scientific, mathematical, computational platform. It was again conceived originally for I guess the hard science, physics, um, and mathematics, but now of course it applies to whole universe of more modern science or multidisciplinary science. So chemistry, genomic, data science, geophysics, all kind of stuff, right? And what you should think of, first of all, as you gain experience, is to work inside the universe of Wolfram Alpha's curated data so that you get familiarity and also you get a verified curated data set to play with, example data or entity type that I mentioned. And once you are good and ready, then you can go to real world data problem and work on real data that's not as clean. It's a bit more messy. It requires a lot of cleaning. And I don't mean to give you a discouraging message, but I always told, I have I raise my arm up and say, in a data science project, and I make this gesture, 80% of the time almost is spent on munching or playing about with data. My Gongkan would be able to confirm. Even though you think that the brain of data science is about analytics, creating model, and testing, and all that, maybe 80 is a little bit pessimistic, but certainly more than 50% of their project time is spent on cleaning, verifying, recompiling, reformatting data, and stuff like that. Okay, right now we are going to, now I'm going to introduce, now Wolfram in this case now becomes the name of the language for programming Mathematica. I hope that's not so confusing. So anyway, so Wolfram is the name of Stephen's last name, all right? Stephen's last name is Wolfram. So that's the name of his company. That's his last name. That's a commercial name, let's say, okay? Wolfram is also like a name of a generic name for ecosystem that includes Mathematica as a computational platform, includes Wolfram Alpha that has a knowledge base. It's also the back end or add-on for large language model like ChatGPT and all that. Finally, I think maybe recently, instead of calling it Mathematica programming language, it was named, the Mathematical programming language is named Wolfram. Okay, so that's kind of like confusing. So I'm going to introduce Wolfram not as an ecosystem, but as a language you use inside Mathematica. Okay, so first thing is just like, hello, how are you? Or anytime you learn a new language, you need to know the primitives. Okay, so what's the primitive? Okay, what's the primitive? Primitives are like, again, hello, how are you? Hello world kind of thing. And it's the most basic concept. Now, I already told you that Mathematica function most naturally as a functional language, right? As a functional language, meaning when you communicate with it through the use of language, either built in or something that you create called user defined. Okay. But before we get to that, computing. What do you think computing is all about? Computing is about doing something and getting some result, right? But you can't just talk about number 7 without holding it somewhere. Okay, so when I tell you that 2 plus 3 equal to 5, right? Right? That's a nebulous thing, right? I said it, it's gone, it's in the air, it's gone. Okay, but while I said it, you had a placeholder in your head. You hold the number 2, you hold the number 3, you apply operation add, and the result is 5. And you hold it. There's a placeholder for number 5. Obviously, you throw that away because it means nothing because you're not using it anymore. So, but the concept of assigning value to a variable or having a place to hold it is fundamental to working with computer, right? Because you're not going to have any kind of mental representation. You're going to have something that is common to both you and the computer. So you need to hold it somewhere, right? So that's where assignment comes in. Assignment is probably, in my opinion, anyway. In fact, if you go to deep data computer science, you might say that assignment, flipping the binary from 0 to 1, 1 to 0, that's the most fundamental thing, right? So assignment. So let's double click on this and see what we got. Assignment, well, obviously, assignment is done with equality sign. Okay, one time, one equality. X, okay, so type in with me again. This is I mean it, even though it looks trivial. Again, go through with me. Okay, by the way, I'm not gonna ask for a lot of verbal response from you guys, so class participation that way doesn't really work. But what is going to happen is within, say, 5 minutes of class ending, every one of you will send student ID, okay, student ID dash 01. Oh, in this case, it's 02. Student ID dash 02.nb. Submit that on my class view. And so it can be anything on there. Okay, basically the example that we work through, if you're not doing anything, then it'll be blank. If you keep typing in, as I say, okay, you're going to have a whole bunch of example that you learn. That's what you hand in at the end of the class. Okay, that will be both your assignment and participation. So again, your student ID, so 856 blah, 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 dash 01.nb, and then submit it on my course view. The TA is going to create a submission. We do this every class from now on. Obviously, this class is going to look very simple. So x might equal to 1. X is the left-hand side. Equality is the operator. 1 is the right-hand side. Right now, right now, X is blue because the computer doesn't know what X is. Equality is black because computer knows what equality is. Equal sign is 1. It also knows what 1 is, right? So when I did this, I am saying, please assign what's to the right to what's to the left. So I'm going to shift enter, blah. So now I get echoes 1. But this one, if you think about it, it's not just the one that I sent. It's actually the one that is the value of X, right? Obviously, if I put in 1 here, right? If I put in 1 here, enter, that's also 1, right? But here, I don't mean just that. I mean that X. So if you think of it deeply, I'm assigning 1 to X. And this one here is the value of that assignment. It's the result of that operation. Okay? Now, it's a little bit hard to get your heads around, but I really want you to see 2 things. One's the action. One is like the signature or the appearance or the output of what you get as a report. Okay, I'm going to use the word report. Okay, so when you did this, 2 things happen. X, which was blue because the computer doesn't know what it is, becomes black. It becomes something that it knows. And it knows X to be equal to 1. Now that's the action. That's the action. If I did this, y equal to 2 or 3, whatever, and I put semicolon, what I do is I suppress the report. So the action is done still. Y is equal to 3. But when I shift enter, I don't get output because I don't report anything. Okay, so there's an action and there's the report. Okay, now this thing happened to be an action and a report. So let's do this again. What happens when I do this? Shift enter. Well, I'm making it many steps, right? So it's going to give you 123 because the new action is to assign 123 on top of what's old. So forget about what's old. Okay, so now it's 123. Do I report it? No, because I have semicolon. But now I call it back again. So yes, it's going to report it. Okay, so this is going to give you this. Now, notice that this is two action, right? X equal to 123 is action number 52. X is action number 53, and that's why you get 53. That's why if I did this, 52, 53. Okay? Now, contrast this with X equal, contrast it with just this. It's one action. 54, 54. Okay? Now, these are all very subtle points. Okay? It means nothing. Come on, I'm just assigning a number, right? Again, I tell you that this is what I do very well. I make easy things difficult. Okay? X is equal to 123. That's very easy. I'm going to make it very difficult. Okay? So you can see that there are different actions that's going on. Obviously, if you have the conceptual understanding that's kind of bulletproof, right? With X is equal to 123, then when you go on to something more advanced, more complex, you will have a better sense of what's happening to your variable. Okay, let's do something else. Okay, let's do it one at a time. Maybe I'm too greedy here. Okay, X is equal to, let's do this. Yeah, let's not do this at the same time. Let's do this. Okay, what do you think is going to happen? The right hand side, it takes X as is or as was, as is, which is 123, subtract 111 from it, and then give it to X. What happened? Gets replaced, right? Okay, and then report. Now, if I did this, and on top of this, now X is equal to 12. If I did this, it's the same thing as X is equal to X divided by 3. I'm just making a shorthand. Okay, so this kind of thing, add equal, divide equal, plus equal, multiply equal, divide equal, add equal, minus equal. These are all the same thing. Meaning it does the operation and then assign on top of the old stuff. So what do you think is going to happen to X? X is going to equal to 4, right? Because now, okay, so now that's what X is. Now, get into the habit of this. This is called clear or clear all. Okay, clear all. Okay, clear. There's subtle difference between clear and clear all, but you can just say clear. Okay. Now, once you've done this, and I do this in the textbook, I put it in gray because it doesn't add to the narrative of the textbook, but I do this just to keep things clean. Okay. Because right now, if I type in X, it's oops. Again, it's default to text, and I'm gonna get the default to. If I type in X, it's gonna equal to 4. Y is equal to 3. Imagine I go to the next chapter and I use X and Y again. I want it to be blue, right? So what I need to do is to clear it. Okay. So let's clear that. So that's the function clear. Now, one thing you have to memorize is the argument to the function in Mathematica uses square bracket. Okay. Python use no. Okay. Curve. So clear what? Clear X. And in this case, you might as well clear Y too, because I don't need them. Notice they're both black. Once I clear them, they're both blue, right? So now I call what is X? I don't know. X is X. You give me X, I give you X. Okay. This is what Mathematica does me, it doesn't know. Okay, fine. So we cleared all because this functional programming paradigm again. So defining, okay. Now this is gonna look a little bit difficult and take your time, but type in the way I do. Type in the way I do, okay? I just want you to suffer a little bit, okay? By the way, I make my text available, but I want you to key in the mathematical function. I never give you something you can shift enter. But let's do one at a time, okay? This is what I mean by defining a function, okay? Actually, this is a little bit difficult, so you may not be able to key in everything exactly as is, so don't worry, okay? Don't get lag behind, just follow the lecture. Now, when I say x is equal to 3, I'm assigning a value to a variable. But I told you that the power of functional programming is that you communicate with computer what you want to be done using function calls. But once you define a whole bunch of function, you might as well what? Define your own function. This is what you do. You define your own function, okay? Now, don't memorize this because we're going to do slightly different, but you can think of this as this is my function. The left-hand side is a variable. It's blue. It has many lines, but in Mathematica, all you need to do is use character. You can't start with a number. That's the convention, and you can't put a space between. And unlike Python, you're not allowed to use underscore, okay? Because underscore means something entirely different here. It means pattern matching, okay? So you don't use like a name of variable like a house price, house underscore price. No, you don't do that in Mathematica, okay? What you would do, you do this. You would use house, something like house, use a small letter because you create, and then price is big P, something like that. This is what I do, okay? You can use HP or whatever, but this is what I would do, right? So instead of assigning it a value, I assign a function. Okay. Now this is how cool it is. All I do is I define it as a function, u of x and t. How many of you have friends in engineering? No? Okay. Well, this is what they would learn in second year. Okay. It's very difficult to solve, but in Mathematica, you see, heat is a function of position and time. Okay, basically, I'm just going to give you a quick lesson in engineering. If you have something that's hot, at the location X, at a given time, U is going to give you the temperature, how hot it is. Now, if you have experience with heat, you will notice something. Well, first of all, you will notice that if this is hot and the room is cold, this thing is going to get cooler over time, right? Well, why is that? If this is hot and I put in the room that same temperature, is it going to cool down? No. So cooling down is not an innate property of object, right? It's how hot you are relative to your neighbor. Okay. Well, long story short, the more difference you are with respect to your neighbor, so in other words, if you're really hot and your friend's really cold, if the second derivative, but anyway, just kind of like the difference, is gonna cool you down. It's gonna heat this thing up, and it's gonna do it gradually over time. So that's what physics of engineering is. But now, this is what I do. Shift enter. See? Here's what I did. I defined this function I haven't told you what it is because, you know, there's no science, there's no engineering, right? This thing does math, but it doesn't know what U is. In fact, it doesn't even know what X and T is, but you know. You're going to use T to proxy for time. You're going to use X for precision. You're going to use U for temperature. Okay? Even without doing anything, I'm going to define heat equation with this. This is actually what your second year engineering friend does. Change dx dt, remember that? But this is partial. So this is delta of heat with respect to T. Basically, partial differentiation of this thing with respect to T is equal. Now, this equal is a double equal because you're not assigning. You are saying that the left and the right hand side is a statement. The left hand side is equal to the right hand side. You're not assigning. So if you're not assigning, you use two equality. Just memorize it for now, okay? But this is it. This is all of physics. The differentiation of the heat with respect to position is equal to second derivative, in other words, derivative twice of the heat with respect to, differentiation of heat with respect to time, okay, how temperature gets cool, is equal to second derivative of heat with respect to position. That's why if you're hot and your friend is hot, you don't cool down. But if you're hot and your friend is very cold, the second derivative of the temperature comparing you and your friend in position is going to be big, right? So if you're hot-headed, your friend is cool-headed, you are going to cool down really fast. Now, unfortunately, your friend will probably heat up as well a little bit, but never mind. But if you're the only hot one, and the friend to your right is cool-headed, the friend to your left is cool-headed, and the friend of your friend is all cool-headed all the way down. You're the only one hot one in the room. What's going to happen? Are they going to heat up? Not really, a little bit. It's you that's going to cool down. That's called heat equation. This is physics. This is engineering. This is also the model that's used to model financial derivatives, which is a very exotic thing that you're not aware of. You don't have to be aware of yet, and won the Nobel Prize in economics in 19-something. Okay? But anyway, the idea here is that I can define this as this function. I can define this as equality. Think of how cool that is. Okay, so I'm not saying x is equal to 3. That's assigning value 3 to number x. I'm saying that from now on, every time I see the word heat function, Mathematica will know what this is. It's the function of x and t. And it's going to know too that if I add physics to it, add engineering knowledge to it in the form of partial differential equation, second order partial differential equation, because you do it twice. So this here is second order PDE. Okay, you can call this thing my equation, and then you can do all kind of analysis with it. All I'm doing now is just designate it, so never mind. So I'm just going to clear. Okay, so now it goes back to blue. Now I'll come back to this heat equation just to show you how cool this thing is. Okay, but right now you can say that I'm not just assigning a value. I can assign a function. I can assign equality, meaning that left-hand side is equal to right-hand side. So if I have any of you take physics in high school that go as far as electromagnetics, right? That has 4 equations, right? So now I can name the set of 4 equations as Maxwell or something like that, right? Okay, and do some analysis on it. I haven't done. So the first thing you need to know, the primitive, is how do you assign things. And now you assign, so, and previous thing you can assign as well, like chemical data. So Y So instead of saying X is equal to 3, X is equal to chemical data of, I don't know, water. Oops. Okay. This is what I mean by multimodal object, right? So now X is equal to this. So every time I see X, okay, it's a water. So let's clear that. So that assignment is the most fundamental thing. Now, next, and this is because in programming, anything worth doing is worth doing many times. Okay, what do I mean by many times? Two meaning. Do the same thing over and over. That's like a loop, right? Or do the same thing to many things, right? So I'm a very, strict teacher, old-fashioned. I take my stick and I hit you over the head 5 times. That's a loop, right? On the other hand, if all 5 of you are late to class, I hit the first one, then I hit the second one, hit the third one. Same action, different object. Now, a lot of time I would do that. So the first one is a loop. The second one is multiplicity of subject or object. In this case, you can think of my action as hit a list of 5 students, right? Now, what's cool about a list? Well, first of all, it contains the thing that I can apply the same kind of action to, right? It's also ordered, okay? So let's say I hit the first one really hard. Second one, I try to hit as hard. By the time I get to the 5th one, I don't have strength anymore, okay? So I hit the last student very soft, right? So obviously you would say, hey, if I'm going to be hit, I like to be the last guy rather than the first, let's say. So there's a sense of order, okay? And even though, yes, I'm doing the same action, maybe the action can be different, okay? Or let's do a list of students. Let's say the first student is the one who arrives early. The second one to arrive on time. The third one is late. I can say, this is my list of students, guys. I would use entirely different action. The first one I will reward. The second one I'll say, it's okay. And the third one I'll use my ruler to hit. Okay, I'm being mean. See what I mean? So once I organize similar kind of object, but with Mathematica, of course, like I said, there's this thing about multimodal, multi-object type. So maybe the list doesn't have to be the same kind of object. So I can have a list of student, comma, dog, comma, computer. Can I do that? Yes. Okay. So anyway, the whole point is that a list helps me basically organize things I'm going to do action to. It is list. So list, how do you say it's a list? Well, so list of hello, comma, 7, comma, blue. Okay, this is a list. Now, in fact, nobody write the word list. I'm just going to write like this. So it's a curly bracket. Okay, curly bracket. Why? So RGB color. Let's say red, green. Now, blue shouldn't be so bright, so I'm going to give it 0.5. Why so blue, but dark blue, right? Hey, it's a list. It's a list. Okay. What's good about a list is it can be as long as there's computer memory enough for it, right? So now I don't have to refer to the whole thing. So I can say, this is X is equal to this. And now, because X is a list of things, I can access individual members. Okay. So remember the function. The function uses square bracket, right? Now, X is not a function. X is a list. but there's a shorthand for it that say take, right? Okay, but let's do this. Item? Yeah, I don't remember. Anyway, there's a function that takes element of it, but why say take element of this? Just say x, and now this is the only exception because you want to indicate position. Oops, echoes again. Instead of one bracket, use two bracket, and automatically you get this kind of thick bracket. And now, guess what happened when I do this? One. I put in the word one. What do you think is going to happen? It's going to access the first element. Why so? Right? Okay. Now, what if I want the last one? I can also do this, -1. So that coming from the other way, that's going to get the last one, right? Okay. Now, let's say this is only 2. Let's add a few things. Let's x is equal to okay. What's it? Caffeine. Okay. So now x has got 1, 2, 3, 4, 5 things, right? So whenever I say x, it's going to give me my 5 things. If I want individual element, double bracket, 3, 4, 2. Okay. Now, 1, 2 to 5. It's basically 2 ... 5, right? But in Mathematica, and this is the only thing that I find very unelegant about this, is the use of semicolon. Okay. So A to 5 looks like this. Conceptually, it means take the list AX, get the second element all the way to 5th element. Okay. The reason they use this is because this one is not used very much. Okay. So it's not that pretty. Anyway. So that's 2 to 5. Okay. What if 2 to the end? It's the same thing because 5 is the last one. Or from the beginning to 3. Right? So third one. Okay. So basically, this is all the way to. Now, what if I did this? That makes no sense. But certainly you can guess what it means. It's everything, right? Yeah. Start at the beginning, go all the way to the end. Well, it's the same thing. So they use the word all as well. Okay. Now, that's a list. Yeah. So that's a list. There's a mathematical operation I haven't told you. I can check if things are equal. For example, okay, can I do this? X is equal to 7. Yes, I assign X to 7. Okay, let's do this. X equal to 7. Now this is now an equation. But unlike the equation I mentioned earlier, I use double Greek sign, so equation as well, right? Unlike equation earlier, I'm not making a statement. This one, it's like asking. So I am asking, is X equal to 7? It's like in Excel, you can say true or right. So if X is equal to, okay, so you use it's true. So this is going to give you True. Is X equal to 8? 7? False. Okay. So this become operation logic. Okay. So now you know equality as assignment, equality twice as a equation. If you use equation like this, then you're asking, is it equal? Right? You're not stating, you're asking. Okay, anyway. So I can do this, right? Equal to X. Is it the same thing? And in fact, truth is one of those things where it's everything has to be true, right? So if A is equal to B and B is equal to C, then A equal to B equal to C is okay. Well, first of all, I have to clear X because see, I just made the mistake of assigning X twice. So now X is 7. So let's go back to here. Let's do this again. So now X is a list. Okay, now X is a list. So X all the same thing as X this is equal to the same thing as this. And is it equal to the same thing as X? What else? Now happen to be in this case, because X has 5 elements, 1, 2, 3, 4, 5. I can put 5 here, right? Right. All these are true. Okay. So this is a shorthand for this is true, and this is true, and this is true. Okay. Anybody knows what a symbol in computer for and? It's actually an and sign. Yeah. So you can do this as well. Okay. But obviously this is kind of like too long. Right. So these are all, you know, easy things. Now, notice this is list. Access individual number. Now I'm going to say list of list. Okay. Once you got list of list, your world is endless. Why? Because when you learn in your linear algebra, you can have a list of number, an array of number as a vector. And then you have matrix. A matrix is a bunch of rows. Each of them has a bunch of columns, right? So likewise, I can make, now let's think of it this way. Let's think, you guys know convention, right? The first index is always the row number, right? Second index is the column number, right? Okay, so let's do that. Let's go to this sheet. Now, let's make it pretty. A11, okay, is a leftmost, topmost A11, right? So what's to the right of A11? A12. Okay. Now I'm going to be a bit fancy here. Might as well, but time is short. Instead of A11, I'm going to type control minus. Control minus. Basically, that put into subscript. So now I'm going to have 11. Okay. And then use the right arrow. So get out of the subscript, comma, A subscript 12, comma, A subscript 13. Okay. Now this thing has to be the first row, right? So I have to call this a list. Right? Now what's a list of lists? Well, it's a list of list. Right? So let's do this. Type exactly as I do. So now it makes sense to say this is the second row. So I'm going to call it 2, 2, 2. Okay. Now, mathematically, I'm going to call this my matrix A. Now, normally matrix is used capital letter, right? Okay, but in programming, because the capital letter is used for like a reserved function, I tend not to use that. So I would say something like A matrix MTRX is equal to this. Okay. By the way, you can enter, doesn't matter. It doesn't care. It's not like in Python, you have to say what three row or whatever, three dash. You can do this. Okay. Now it's a list of lists. It's a list of two things. Each thing is a list of three things. Say after me in your head. This is a list of two things. Each of those is a list of three things. So in this case, can you imagine what kind of matrix would this be? It is a 2 by 3 matrix, right? Now, because list is a computational object, right? Whereas matrix is a mathematical object. In this case, yes, you can use this to represent a matrix, but Mathematica is still going to think of it as a list of lists, right? So let's do that first. Let's do that. It's a list of lists. Shift enter. It's a list of lists. Okay. Now, if I did this, AMTRX, okay, double bracket, and I put the word 2, what do you think is going to happen? It's going to take the second row, right? Well, let's try something else. Let's try 3. It's going to get error because it's a list of 2 things. It's not a list of 3 things. So if you give it out of range, it's going to give error. Fine. So if I did this, I'm going to give it 2. Right? Yeah. It's a list of 2 things, each of which is a list of 3 things. But it's a list of 2 things. So if I'm going to take the second element, it's the second row. Now, what if I want A23? What would I do that? How would I do that? Well, this thing is a list. So obviously I can do this, right? This thing is already a list. So I just do this. Cool. Yeah. Now, oops. I hope you see where you can guess where I'm going with this. Obviously, this is going to be too cumbersome to type. So another way to access this is 2, 3. Guys, see that? Now, again, I'm going to make easy thing difficult. What does it say? Take the object called a matrix. Take the second thing. So that second thing is a row. Take the third thing in that second thing. I get this. Now, if I did this, it's almost like I'm going to take 2, 3 thing. So this becomes like a coordinate, right? So this is kind of like, you can think of this as this is sort of like successive process. Go down to the second row, then go down to the third column. Whereas here, I go directly to 2, 3. It's the same thing. It's the same thing, but I want you to think differently. Okay, so I can say that this is a shorthand for this. Yes, it is. But I also want you to have this mental map that actually, you know, it's the same thing, but it's a different process. The first one, go to the second row. And for that second row looks like this. I go to the third column. Whereas this one say, go 2, 3. So just aim for the second row, third column. Boom. Right? Okay. So that's how you access lists. So once you have this, boy, you can do all kind of stuff now. Okay. I'm going to cover the last thing, which is concept of function, but you will not have that many functions. In fact, when the book comes, I want you to read ahead a little bit. Okay? So we got this, right? Okay, now let's go to the third thing, the third primitive. Because the first primitive is how to do assignment. Okay, let me collapse them. Second primitive is list. First primitive is assignment. Third primitive, now we get to function. Now this is where the fun begins. Okay, function. So function, functional operation. Okay, just about every mathematical input is a function call. Even I put in the word 7, it's just saying that echo back to me what I just write. So it is a function. The function say, give me back what I give you. And the input to that function is 7. I give you 7, you give me back 7. So it's a function call, right? So when I type in 7, it's like echo to me. Now, the function uses square bracket. I already mentioned that, right? Now, there's some function I'm going to call prompt. It's a function that cannot have any argument. Okay, y is an f of x. What if y is just an f? What if y is just an f? Is there such a thing as a function with no argument? Guys, is there one? Well, in theoretical, there isn't. But in practical, you can do that. For example, a function is, give me the time. Yeah. Now, implicitly, I had to say, give me the time, Thailand, right now. But, you know, nobody does say that. Hey, what is the time right now in Thailand? Well, you are in Thailand, right? You're just asking this question. Why would you say that many things? So you would give a function that has no argument, time. So that is what I mean by prompt. For example, now you don't, well, you can, but you know, it's a little bit silly. Okay. So this function, you just say now, Tuesday, 13 August, 1540, 18 GMT plus 7. Okay. What's tomorrow? Well, again, there's only one tomorrow, Wednesday, right? So I would call this thing prompt. Prompt. Okay. Now, this is not necessarily a standard, you know, terminology because it's so trivial. Nobody that really calls it. Now, next step up from prompt is a command. A command is a function that conceivably takes an argument, but it doesn't. Not right now. So, for example, I happen to have this notebook saved in some directory. So when I give this command, okay, notice I can put in input, but I don't. So it's also like a 0 argument. Okay. Again, I'm making easy things difficult. So this is absolutely no argument. This is 0 argument. Okay. I happen to save it under lecture notes, whatever. Okay. Now, I can do this. Another thing, so the distinguishing feature between a function with no argument that I call command and a function that cannot take argument, which I call prompt, is that a function with no argument sometimes can take argument. Okay, I'll give you example later. Well, I can do it now. For example, I can say, yeah, I can do it. I can say, oh, let's use the thing, date object. Okay, again, date object is it's like to get something like this, except it doesn't have to be now. It can be whenever. So if I don't say anything, it's going to act like a prompt. So this thing is the same thing as now, right? Which is actually slightly different before because it was 1540. Now it's 1542, 34. Okay. But I can certainly say date, object, and maybe something, add something like tomorrow or something. I don't know. I don't know if this works. Let me see. Let me see if this works. It works, right? Oops, it works, but it echoes. You just have to trust me that when I make easy thing hard or make a big fuss out of tiny distinction, it's going to save you later a lot of pain when you make silly logical mistake. I hope anyway. Okay, so see, so when I do this, it acts by default just like now. Oops, sorry. It acts like now. In fact, let's try that. Okay, so now there's only one now. You can't now tomorrow. Okay, date object, yeah, you can have date object anytime, any day, right? But if I don't say anything, it's going to assume now. If I say tomorrow, it's going to say tomorrow. Okay, if I say something like, I don't know if this worked, but let's say 18 October 1968. Yeah, see, basically data object just gives you that kind of format, kind of looking thing. Fine. Now let's go to univariate function. A univariate function is a function that takes unit variable, takes one variable. When I say takes one variable, I mean it takes one variable. It's not an option anymore. Here, it also takes one variable, but it also takes no variable. Here, exponential makes no sense if I exponential nothing. Well, actually, this one happened to make because that's actually E, but maybe, I don't know. Okay, let's try that. I've never done this. Let's try it. Let's do this. How about if I did this? Okay. It expects something. So if you give it 0, it complains. This is an error function. Okay. You can leave that in your workbook when you turn in that, so you learn from error. So now exponential 1, 2, 3, 4, right? I think it was. Okay. Exponential. Here's an interesting thing. Why do I get different kind of format? Well, let's do this. Now this is you can say it's a language convention, but the convention is arrived at because this is what the community, the scientific community, tend to like. In Mathematica, okay, what's better, 1/3 or 0.333333333 infinity? 1/3 is more precise, right? So just like in high school or grade school, you were taught that when you have a whole bunch of fraction, work everything out and only use calculator once, right? So you sort of like, there's 9 on top, there's 3 on the bottom. So you divide it by, you do all this simplification, maintaining everything as a ratio until the very last minute, you get something like 72 divided by 1.7 or something. Okay, fine. You go to the calculator. Until then, you don't calculate 7 divided by 2 here, and then 3 divided by 4.5 here, and then add them. You don't do separately, right? Same here. Mathematica try to maintain precise answers as much as you can. So if I did this, it's going to say exponential 12. It's going to give you this. This is Euler's E, right? That's 2.71 something something. Again, this is conceptual. As far as mathematics is concerned, this is infinitely transcendental, right? In other words, you don't get this finite cutoff, e to the 12. But if I did this, let's try this, 12 point. I'm trying to communicate that I want a number. See that? Back again. Now, obviously, you can force it to be number. And this is a function, a built-in function also. Okay, you know this first built-in function, exponential. Here's a second built-in function. If I end up with anything symbolic, give me number. Okay. Now, key in after me, escape. Escape. Okay. PI. Escape, PI. What escape does is it goes to special character. That's basically, okay. There's this thing, palette, called special character. Okay. And I can get my pi from here, like a symbol or, okay. But anyway, the shortcut is good because the shortcut also gives you option to choose which one you want. Escape, P. Now it's make all kind of suggestion. Is it pi you want? Is it phi you want? Is it phi or phi or psi? Okay. Well, I want pi. Happen to be the first one. Okay. Now, because if I did this, okay. Phi, I get phi. Okay. What's phi? Nothing. Means nothing, right? So escape. P phi is nothing. Okay. It doesn't know what it is. It doesn't know what it is. Now watch this. If I do the same thing, but instead of phi, I get escape P. Let's go to pi. Enter. It looks like I'm doing the same thing, right? It also doesn't know. But here's a fun thing. Okay, before that, this is a character, right? If I put n around it, it still doesn't know what it is, right? But watch this, yeah, watch this. Because everybody in the world knows pi is 3 point. All right, so all this is meaningful and useful. And by the way, this is a pi is going to show up all the time. So that's infinity, so that's e. Basically, logarithmic function, exponential function, some trigonometric function may be useful, but certainly in data science, you see a lot of it. So you can see that why, it does this kind of thing. Okay, fine. So that's function, right? Function. So this function happens to give you a number, e to the 12. This is also a function, right? What if I put something that a, well, it doesn't know what a is. It doesn't know what a is, but it knows what exponential to the a is. So it's exponential to the whatever you don't know. Okay, it's giving as much information. This is extremely intelligent. So it's not just, straightforward variable name. Okay. Now, what else? Now, let's say I assigned earlier. I think I was in my example, I assigned earlier. I haven't. Have I not? Okay, I haven't. But let's say, okay, let's do this. Let's go to this guy that we did earlier. Okay, matrix. Okay, matrix. Now, watch this. Matrix is a single thing, right? So you can imagine that it could be an argument to a function. In fact, if I did this, dimension, this is also a built-in function. You will see that As I type big D, okay, it start making the suggestion, and I just tap. Okay, that's what I want. Dimension of a matrix. What am I gonna get? 2 by 3. It's giving you an answer in the form of a list, but you can understand what that list means because the first number is the number of row. The second number is the number of column. Now, if I don't use the word dimension, I use the word length. What do you think is the number you're going to get? It's the length of the list. Are you going to get 2 or are you going to get 3? Anybody? It's going to get 2, right? Because at the top level, it's a list of 2 things. It happened that each thing is a list of 3 things, but at the top level, it's a list of 2 things. Now, if I did this, how about length of the second thing? Now I'm going to get 3. Okay. And now, notice this is 3. If I put in dimensions, what am I going to get? It's also going to be 3, but. Dimension you saw earlier, it gives you an answer in the form of a list. In this case, it's a list of 1 thing. Okay. Last week, I talked to you about computer screen as a matrix, row, column. I told you that a red, green, blue picture, computer screen is a tensor. 512 by 1024 by 3. So it is a list of list of list. If I give this object to the function called dimensions, what am I going to get? I'm going to get open bracket 512, comma, 1024, comma, 3. Right? If I store video data, 1 minute's worth, it's going to be 512 by 1024 by 3 by 1 minute at 60 frames a second, 360 or 3600. Yeah, 60 seconds a minute and 60 frames per second. Okay, right? So now you can access individual. This is it, guys. From now on, I can say, I'm not teaching you anymore. I can drop date right now, and all you've got is the understanding that there are built-in function, there are way to define function, and it's playing with lists. Now you just go through like a user manual to find in the built-in function. You can learn everything by yourself, technically. But obviously, I would not. I try not to drop date today, and I'll try to teach you again, next week. But this is it, guys. The basic. Now, in computer science, let me backtrack to history. When I was your age, if we were to study computer science, we would learn about data structure. Okay. Well, here, things are both more complicated and simpler. Data structure in my day would be like studying tree and ring and all kind of stuff, table. In your day, today, the abstract data structure that you need to know, you only need to know 2 things: table and graph. It just turns out that each table can contain elements that in itself can be very complex data structure. It could be tensor inside that. Okay, but conceptually, guys, it's a whole bunch of tables. Once you know table and you know that table can be nested into table of table, you can do table of table of table, right? And if you stop at table of table, you have a matrix. If you table of table of table, you get a tensor. Table of table of table of table of table of table. It's also a tensor. Okay, they don't make more words from there, right? And then you can do matrix multiple. So your life is set, right? And so why is list the most fundamental? Because it allows you to stack things. Once you can stack more than 1 thing into a vector, You can stack more than one vector into a matrix. You can stack more matrix into a tensor. Then it's endless, right? So with that, okay, with that, okay, let's do something else. Now this is where, you know, things like Python would not help you. It doesn't have this kind of analytical factor integer. Okay. Now these are very high level way of saying what you want. In here, there are, I don't know how many lines of code hidden for you, but you know what they say? Anybody? Well, if you live to be like about 80 years old, that's how many days on Earth you have. But anyway, I chose this because this happened to factor into integer. It has how many 2? 3 2s. How many 41? 141. So let's try to verify this. There it is. Okay, how do you get the superscript? Control hat. Okay, so let do this with me. 2, oops. Oh, every time I press this, it echoes. 2, oops. 2, wait. 2. Control hat. Wait. Control little hat. Okay. This hat. Chinese hat. Oh, Vietnamese hat, I think. Okay. Okay. To the power 3. Okay. Multiply. Now, Mathematica use multiply so much. You don't need to do this. You just blank. Okay. And then it would know that it's a multiplication. Okay. So let's 2 to the 3 times 41 times 89. See? Conversely, well, then, so you can do this kind of factor integer. Okay. Now let's cheat a little bit. Can you factor integer this like this? What's going to happen, guys? See, just by putting a dot, I'm saying this is a number that has numerical precision of 0 decimal, but it is not an integer. This is how clever you hide this kind of like you know, in some other language, you have to say that this is a type integer, this is a type real, this is a double. You may have friends who say double X or float or something like that, double precision. Now it knows that, hey, this is not legit, guys. This is not legit. You're trying to factor integer something that you said so yourself is not integral. Converse, as opposed to something like this, where you put a number, oops, that does not factor nicely. It doesn't factor, but it's still an integer, right? So it's valid. Hey, you can't take it apart, so it's just a number by itself, right? Okay. But if you can take it apart, certainly this will find for you. And you know, you guys remember in high school you were doing something like a quadratic formula and something like that, right? So yeah, same thing here. So let's say I can say factor, I think a, oops, is, oops, a square plus 2ab plus b square. Now you know this because you know you did this when you were in grade school. Oops. I think it's find root or find factor. I'm not quite sure. Let's try. No, not quite. Anyway, it should factor. Oh, AB is not A times B. Okay, A blank B. See? it does this for you. Now, obviously, it's not, once it does this, you can imagine that for a more complicated function, it may not work. Sometimes it doesn't factor. Sometimes if it doesn't factor, it's going to give you this, right? But sometimes it does. And some even polynomial of second, third order, whatever higher order, it will try to do that. You can't do this with general language, you know. Try to do this with Python. Okay, if you can do this in Python in less than 1 page of code, I'll give you an A automatically. Okay, I'll give you, you get a bachelor degree. No, I can't give you a bachelor degree. I'll give you an A. Okay, do this in Python in 1 page. I'll give you an A. Okay, but this is analytical. It understands that A and B are things that I don't know, right? Anyway, so this is concept of function, blah, blah, blah. Now, the last thing is, I'm not gonna go to I'll come back because we kind of like went a little bit over time already, but certainly let's go back to this thing. Now, I told you that this is a list of lists, right? It's not technically a matrix, right? But of course, this being good for mathematical publication, it's going to give you the right format. So I can supply this to a function called formatting function. So let's say a matrix form, okay, matrix form. Now it looks really nice, looks really pretty, okay? But you know, when you do something with it, you do with this thing, okay? But I think, let's see, let's try traditional form maybe. Traditional form. Ah, so it's even better, right? So if I want to publish a paper, look, that's a script A. That's like a very classy way of doing A. Okay, so matrix form, just stack it up, but it's still this kind of A. This is not elegant A. So traditional form. Now I want to show you that you can do this thing. Okay. Now this is from high school. I'm going to integrate f of x. Now we'll learn a little bit about how you expect to do this. Okay. Integrate, you would go to, basically you type in F1 and it's going to take you to the help page. It's going to say, okay, the first thing put in the function, second thing put in the range. And in this case, common sense should tell you that this is an integral from A to B. Okay, well, let's make it escape infinity. Escape in what's infinity sign? Okay, now what do you think it's going to look like? Because I put traditional form to it, you bet it's going to look nice. Oops. Oh, forgot to clear X. Because now X is an object, it's taking serious. Okay, now X is generic. See? Traditional form, it gives you this. In fact, I've actually published things on just use. So this is even better than LaTeX, guys. Think about it. LaTeX, you have to basically do code to make the picture. But this is actually better than that. You know why? What if f of x, okay? So let's say A to B. Okay? Now LaTeX can do this, right? LaTeX can do this. Look pretty, right? But can LaTeX do this? Okay. Can LaTeX do this? F of x, oops, sorry. Integrate of f of x. Okay. But f of x, instead of f of x, I put something like x to the power 3. Oops. 3. Okay. See? Now if I put if I put a traditional form here, it's going to put traditional form on the result. But see, this is analytical, guys. Again, if you can use Python to do this in a page, I'll give you an A. Okay, because this is actually math, right? So you can do something else. I don't know. Sometimes it works. If it doesn't work, some functions are not integrable even by the smartest mathematician in the world, right? In which case, this function, they will have no answer. Yeah. But certainly if it's something that has an answer, yeah. Okay, it was kind of stuck on something else, right? So it's better than Python, it's better than LaTeX. It's like you have one thing. I want to show what it looks like in a math book, fine. I want this to be solved analytically, fine. I want this to give you a number, put an N in front of it. Yes, it's going to give you a number. Okay, and you never have to basically go from one platform to the next, right? You don't have to say, go to Wikipedia and ask for E to 10 decimal digit and copy that and put in a Python code, and that's your approximation of E to the 10 digit. This is literally E. It's only when you ask, I want finite precision, it will give you finite precision. Not until you ask. So anyway, so this is why am I giving you this? This is not supposed to be fun for you because the primitives are not fun. Primitives are like A, B, C, D, E, F, G. You just have to memorize A, B, C, D, E, F, G, right? The fun starts next week. When you start to play and you will see the power of the function. You can look ahead when you get your book. I may not be here all week. I think what I'm going to do when the book is here, you can go and buy it from Trey, maybe. I don't know. The room 415. Okay, go buy your book from room 415. I'm not sure when your TA is going to communicate. Okay, once you that, please look ahead. I would really like that if you look ahead. Okay, and then try to make, so you, now I'm going to leave because the class is over. You're going to be, you can stay here for another 5 minutes, within which you are to submit whatever you play with. Okay, now if you are one of those excellent students who sort of like make a class note as you go along, instead of doing it in iPad, you do it here. So you say, okay, this is function assignment, this is an example, this is, you see what I mean? So it's going to look a lot nicer. If you did that, obviously, in terms of class participation, you get higher score. You could do that. You could get higher score. But more importantly, it's your own note, right? It's your own note. You can take home, okay? Because it's in your computer now. So you can save this as, student ID /o2.nb.